Okay, this is the video accompanying Chapter 3, Section 3.4 of the book Basic Sentential Logic and Informal Fallacies for Philosophy 10 at UC San Diego, UCSD. What we're going to do in this lecture is talk about the final 3 inference rules. So we already have 5. We're going to get the last 3 in this lecture and work out some examples. So first up is the rule of dilemma, which says that if you have 2 conditionals, which we have here, if phi then psi, if chi then psi, then if you also have the disjunction of their antecedents, so the 2 antecedents here are phi and chi, and we have that phi or chi, you can then infer the disjunction of the consequence, psi or psi, there. And that's fairly intuitive if you think about it. If I know that if I get a dog, then there will be poop in my yard. I know if I buy a cat, there will be fur in my house, right? Suppose I know those 2 conditionals are true. And I also know that I'm either going to get a dog or a cat. I know that that disjunction is true. Well, then I can infer that I'm either going to have poop in my yard or fur in my house. Next up is disjunction introduction. This is one that's actually very simple and very useful, but it gives people a lot of troubles because they overthink it. This statement says that if you have a statement on a line, and that's almost always going to be true. The only time you won't have a statement on a line is in chapter 4. We will start doing some proofs that have 0 premises. And when you first start that proof, you won't already have a line. But that's the only time that you won't be able to apply this rule. Everything in chapter 3, we always start with premises. So you're always going to have a line already in your proof. Any statement, phi, you can derive on a new line a disjunction that has the statement that you already have, phi, and then the other disjunct is any other statement you want. And that's the part that messes people up. It doesn't have to be atomic. It could be a compound statement. It doesn't have to employ atomic statements that are already present. It could just be any statement you want as the second disjunct. Okay. It seems like magic, right? Where did psi come from? But if you think about it, remember the key feature that our inference rules have to have is that they're truth preserving. And this is obviously truth preserving, right? Because if phi is true, then of course phi or psi is going to be true, no matter what psi is, right? Because if phi is true, because a disjunction is true if either disjunct is true, then we already know that this first disjunct is true. So this could be anything. Doesn't matter. This could be a contradiction. This could be B and not B. This could be that compound statement. Doesn't matter. This will be true. So that's why this works and is okay. And then finally, conjunction, which just says if you have 2 statements already on lines of your proof, you can conjoin them into a conjunction. It's sort of the opposite of simplification. Okay, let's see some examples. So I'm looking at this proof just to sort of give you an idea of how I think of these things. And what I'm seeing is that I'm trying to derive a conjunction, D and H or G. Now, D is going to be easy. I can simplify that off here. I can use simplification to get D on a line by itself. And then once I get this disjunction H or G on a line by itself, I can just conjoin, use the rule of conjunction to put them together. So I'm halfway home. I can get D easily. Now how about H or G? What can I do to get that? A couple of things. First off, now that I have the rule of disjunction introduction, if I can get either disjunct by itself, I can disjoin the other one by DI. If I can get H, I can derive H or G, and vice versa. If I can get G, I can derive H or G. The other rule that lets us get a disjunction is dilemma. Okay, and in order to use dilemma, I would have to have two conditionals where these are the consequence. And sure enough, right here, I have two conditionals whose consequence are the ones I want. Do I have the disjunction of their antecedents? Is A or C up here? Sure enough, A or C is right there. So if I can bust this out and bust that out, I can use dilemma, right? I'll have two conditionals. I have the disjunction of their antecedents, A or C. I'll be able to derive the disjunction of their consequence. How can I bust this out? Well, I'll need D or G. I can get D and then use DI to get D or G. So what I did there is I sort of was working backwards. I was looking at what I needed to get in the proof and then sort of figuring out how I could get the components, working from the conclusion back. Okay, so now I'm just going to go through that forward. So first I'm going to simplify D off by itself, both because at the end I'm going to conjoin that with H or G to get the conclusion, but also because right now I'm going to get D or G, and that's by disjunction introduction on 4. Why D or G? Because that's the antecedent I need to do modus ponens to get A or C. Okay, now let me just remind you of the rule of disjunction introduction here. If you have a statement, I can derive a disjunction that has that statement as one disjunct and any other disjunct I want as the other statement. Okay, so I have D, get a disjunction that has the statement I already had as one disjunct, and then any other statement I want as the other disjunct. Now some people might say, and people have asked this question in the past, where did G come from? Well, it came from the fact that I wanted G there. Right? This rule lets me put any statement I want as the other disjunct, and I wanted G. Now I could have put anything. I could have put X, and that would have been a fine use of the rule. I could have put a compound statement, right? Line 5 could have been D or parenthesis R and not R, close parenthesis. So I could put anything there. Why did I want G? Well, because that gives me this antecedent. If I had put D or X, that would have been okay as far as the rule goes, but that wouldn't help me in the proof, right? D or X doesn't do anything for me, but D or G does. D or G lets me use modus ponens on line 1 to then get A or C. Okay, now I have the disjunction of the antecedents. The next thing I need to do is I need to bust this conditional out by itself. Remember, inference rules can only apply, oops, what did I just do here? Okay, I'm now explaining more why I chose G as my other disjunct. Okay, so I chose G here so I could get A or C by modus ponens, right? Now, like I said, I could have said G or D, right? By the way, what do I mean by that? What I actually derived was D or G. Now the rule of modus ponens, I'm now backing up, and this is what I didn't do. I'm just showing you what I could have done but didn't. The rule of modus ponens, the rule of disjunction introduction says that if I have a statement, I can get a disjunction that has that statement as one disjunct and any other statement as the other disjunct. I can put them in whatever order I want. Now in the written version of the rule, the one I already had is the first disjunct, but I could have done this. I could have made the one I already had the second disjunct. That would have been fine. But again, that wouldn't help me. I don't need G or D. What I need was D or G, right? I also could have done this, right, like I explained. I could have had D or if X, then not Z. That would have been a legit use of the rule, but that doesn't help me. Right, the only thing that helps me is D or G. So now I'm back to the actual proof. This is what I really did. D or G, because that gives me this antecedent so that I can get the consequent I want. Now I'm going to bust off the second conjunct here by simplification on line 2 so I can get this conditional. Now I have everything I need for my dilemma. I have two conditionals on 3 and 7, if C then H, if A then G. I have the disjunction of their antecedents, A or C, so I can derive the disjunction of their consequence, H or G. Now, here's another thing. Because I'm making this disjunction new myself, I can put these disjuncts in either order. It could have been H or G instead of, I'm sorry, G or H. Okay. It doesn't matter. It's up to me. I choose to make it H or G because that's the order I want them to be in. Now all I have to do is conjoin 4 and 8. Okay, 4 is D, 8 is this disjunction, and when I conjoin those, I'll have the conclusion like that, and that's 4-8 conjunction. Okay, let's see another example. Now, this proof is pretty easy, and I'm just going to do it two different ways, just as another demonstration of the fact that there's a lot of different ways to do any proof. So here's one way to do it. I look at this and I see, oh, I have the materials I need for modus tollens on 1 and 3. The consequent of 1 is A, and I have the negation of that on line 3. So I can do modus tollens on 3 and 1 to get the negation of this antecedent. Not, if not A, then not C. And then this is the negation of that consequent. So I can do modus tollens again on 4 and 2 to get the negation of this antecedent. C would become not C. And that's the conclusion. So I'm done. Now there's another way to do this proof. Instead of erasing the line 4 and 5 here, I'm just going to leave that up and I'm just going to move down and do another 4 and 5 to show you a different way to do this proof. I noticed that on 1 and 2, I can do a hypothetical syllogism, right? Because this consequent matches that antecedent. So I've got a chain, boom, 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 boom. I can cut out this middleman and get if C then A by hypothetical syllogism. Now, on 3 and 4, I can do modus tollens. Okay, if C then A, I've got the negation of that consequent, so I can get the negation of the antecedent by modus tollens on 3 and 4. So two different ways to do that proof. Let's see another example. Now again, what we're trying to prove is a disjunction, and right now we have two ways to derive a disjunction that isn't already, a component somewhere in our premises. We could, if we derived either disjunct by itself, we could get the disjunction by DI, right? So for instance, if I could get W on a line by itself, I could get W or X by disjunction introduction. And vice versa, if I could get X on a line, I could get W or X by DI. And the other way we can get a disjunction is by the rule of dilemma. Right, if I have two conditionals and I have the disjunction of their antecedents, I can derive the disjunction of their consequence. So that's another way to get a disjunction. Well, I'm noticing here that X doesn't show up anywhere here. And in particular, it doesn't show up as the consequent of any conditionals. So I don't think dilemma is going to work. I just don't have the conditionals that I would need for that. So it's probably going to be, also because X doesn't show up anywhere, it's probably going to be a case where I'm going to derive W and then get W or X by disjunction introduction. How can I get W? Again, I'm just thinking backwards, so you can see how my thinking on some of these proofs goes. How can I get W? Well, W shows up here. If I could get not A, I could get W by disjunctive syllogism. How can I get not A? Not A shows up there. If I could get R or G, I could get not A by modus ponens. How can I get R or G? Well, I can get R right here, and then I can get R or G by DI. So there I was kind of mentally working backwards. Now, if I didn't see that, what I could do is just start applying rules and see if something good happens. And it would pretty soon, right? Because the only thing I can do immediately is simplify R and simplify S. And then at some point I'll say, oh, I've got R, I can do R or G to get not A. And then you would just see moves that would eventually get you to W. So if you can't think backwards the way I just did, don't worry. Just start applying the rules and then look again and see what you can do. But now I know what I'm going to do because I already planned it out. So I'm going to simplify R from line 3. Now I'm going to go R or G so that I can, and that's by DI on line 4, and I'm doing that so I can get the antecedent of the conditional on line 1 for modus ponens. So I'm going to do modus ponens on 5 and 1 to get not A. Now I have not A on line 6, which is the negation of one of these disjuncts, right? It's the negation of the first disjunct. So by DS, I can derive the other disjunct, W. So that's by 6-2 disjunctive syllogism. Now I can just use the rule of DI to get W or X. I have W, I have a statement. I can then derive a disjunction that has that as one disjunct and anything else I want as the other disjunct. The other thing I want is X, because then my proof is over. So that's what I'm doing, W or X, and that's by DI on line 7. Okay, let's do another one. This one is going to be pretty short, actually, but it still requires a little bit of cleverness. So what I'm looking for is D or M. Now, as we already know, one way to do it would be to try to get D or M by itself on a line and then use DI to get the whole disjunction. Now, that doesn't always work, right? It may not be the case that the premises by themselves will derive one of the disjuncts alone. It might be that the premises by themselves will only be able to give you the negation, or the disjunction rather. This is a case like that. How could I get this? Well, it's going to have to be a dilemma. I'm going to need two conditionals that have D and M as the two consequents. Well, I've got that. I've got D and M. I would need the disjunction M or G. But I don't have that. Is there any way I could get M or G? No. Well, the other thing I could do is I do have the disjunction G or G. If I could get two conditionals, G, if G then M, and if G then D, then I'd be in business. And I can get that other conditional because I can use hypothetical syllogism. I have if G then M, these M matches here, so I can get if G then D. And then I'll be able to do the dilemma. If what I just said didn't make a lot of sense, this is what it looks like. So the first thing I'm going to do is hypothetical syllogism on 1 and 2. This consequent and this antecedent match. So I get a new conditional that has this antecedent, that consequent, if G then D, right there. Now, look, I have if G then M, if G then D. D and M are the two disjuncts I want, and I have the disjunction of their antecedents, right? G or G. So those are the two antecedents, and I have their disjunction, so I can infer the disjunction of their consequence, D or M by dilemma. It's only 2 steps, but this is one that, you know, they weren't an obvious 2 steps. Getting that first hypothetical syllogism was key to that proof. Okay, next up, oops. And this is going to be the last example that I'm going to work through in this video. We have 3 premises, and we're trying to derive a disjunction. Again, let's just suppose that I try to think backwards through it and I can't, so now I'm just going to try the strategy of applying rules and see if something good happens. Well, if I simplify R off, that's actually the only thing I can do at first here. Excuse me. I notice right away that I can get R or Y, R or M by disjunction introduction, and I can start doing modus ponens on the statements on lines 1 and 2. So I'm going to go ahead and do that. I'm going to get R or M by DI on line 4. Now line 5 is the antecedent of the conditional on line 1. So I can get the consequent by modus ponens. Now that's a conjunction. Now I can break apart these conjuncts if I want. I'm going to go ahead and do that. If Y then K, I'll go ahead and break off the second one. Why not? If Y then Z. Okay, now what can I do? Well, one thing I can do is, because I can't think of anything else, I've already broken these up. I've done my modus ponens here. Another thing I can do is I can do R or Y to get modus ponens there. Okay, so I'm going to do that. R or Y, DI on line 4. Now I have the antecedent of the conditional on line 2. So I can do modus ponens to get Y or W. Okay, so now all I've been doing is I've just been applying rules. Now, it's not clear to me what else I could do. I could break M off by itself by simplification. I'm not going to do that, but I could. The reason I'm not going to do it is because it's not clear that it's going to help me at all. So now I'm going to go back and look at the conclusion and see if anything I've got here has that conclusion. So it's a disjunction K or Z. Does it look like I could get K or Z by itself anywhere? I don't have Y by itself. I don't have W. If I did, I could do modus ponens to get those. No. How about a dilemma? Are K and Z the consequence of two conditionals anywhere? K and Z, sure enough. So they are the consequence of two of the conditionals I have. Do I have the disjunction of these antecedents, Y or W? Ah, sure enough, right there. So now I see I can do a dilemma. So this is an example where I just applied the rules, broke down a lot of the pieces to get stuff, and then looked again, and oh, the solution just kind of jumped out at me. So I can do a dilemma on 7, 8, and 10 right there. And that proof is over. And that concludes this lecture.